Hello, welcome to this new problem. This problem is about prime factors of a number. What is prime factors of a number? For example, let's take the case of a 12. Prime factors are nothing but the factors of this number that are prime, which means in this case, if you see 12, that is equivalent to 2 power 2 into 3. Why is that? Because 2 is a prime number, 3 is a prime number, and 2 goes 2 times. So 2 into 2. And then it is into 3 goes 1 times. So if you multiply 2 into 2 into 3, we get 12. So this is what prime factors are all about. I mean, if you see 4 also is divisible by 12, right? 4 also goes or divides 12. But since it is not a prime number, we are not taking into account. Okay. So we take only prime factors. So what are we trying to do? If we pass input as 12, then we are expecting an array that should give us 2, 2, 3. And if it's 13, there are no prime factors, so we just return the number itself. If it's 315, then we will return 3357. If you multiply 3 into 3 into 5 into 7, we will get 315. Okay, so this is the expectation. So try to think around this, and in the coding exercise, try to solve the problem. Here as well, we are going to solve 3 times. So there are like 3 different approaches. So the first approach, naive approach, is going to be like something like we will be looping from number 2 till n minus 1, and inside this loop we will be checking whether each number is a prime. If the number is prime, then inside that we have another nested loop that will check whether this number is divisible by this prime number, and if it is divisible, then we increase the power of this prime number. For example, if it is 2, then we multiply 2 by 2, 4. So we check whether the number is divisible by 4. If it is again divisible by 4, we again multiply it by 2, which means we again check whether the number is divisible by 8. Okay, and then we carry on. Got it? So that's what I meant by increasing the power. So this is the basic idea on how to solve this. So try to solve it on your own, and we will see in the solution video. Okay, welcome back to the first naive solution. First of all, let me create a new file. So 08 prime underscore factors.js, and let me create a function called prime factors, and this is going to take a num as an argument, and inside this, if you remember, we need to send out an array of factors, right? So let me create a variable called output and assign it to an empty array. And the next base check is that if the number is less than or equal to 1, then we will just return the output itself, which is an empty array, because for a number which is less than or equal to 1, we don't have any prime factors. Great. Next, we will start the loop. So let I is equal to 2. So we start from 2, and then it goes till num minus 1, and then I plus plus. Inside this, what we can do is like we will check first whether a number or the the number I is a prime or not. So is prime of I. So you see, we need to have a function called isPrime. So what we can do is like we can copy from the previous lecture. So let's take that, and let me paste it over here. So this function will say whether the number is prime or not. Okay, so now whenever a number is prime, what I will do is like let me create a temporary variable called x and assign this I. You will understand why I'm doing this shortly. Okay, next case is I'm going to check while num percentage x is equal to 0. So until this num percentage x, which is initially 2, is equal to 0, that is if the number is divisible by x, then we say output dot push of I. Okay, and then what we will do is like we will assign x is equal to x times I. So basically we multiply, example, if it is 2, we multiply 2 into 2, 4. Next time when it comes 4 into 2, 8. So we just multiply or increase the power of that prime number until this number is divisible. Okay, great. So now when we are coming out of this loop, so we will get coming out of this for loop, at the end we will just return the output. Okay, so that's all actually. So when 2 comes, this will check whether it is a prime. It is a prime, so it will get all the powers of it, and we will be pushing how many times whether it is divisible. And next it will go for 3, and 4, when it comes to 4, it is not a prime number, so it will not go inside this loop. Okay, great. So let's add some test cases as well. So console.log of prime factors of 12, and let me copy 3 more times, and this time 13, 315, and then 1. Okay, cool. Now let's try running this. So node 08, you see the first one is 223, 3357, empty, empty. Yep, this is providing the expected output. Great. So what is the time complexity of this solution? The time complexity is that, if you see, this is trying to run almost n times, and is prime is actually running, if you remember, square root of n, right? So n power 1 by 2 times. And inside that we have a logarithmic operation, because like dividing, and then, you know, whenever you multiply it, it's kind of like a power operation, so it's kind of like logarithmic operation. So overall the time complexity is like n power 3 by 2 log n times. Okay, great. And as for the space requirement, if you're just printing, the space requirement would have been like big O of 1, but in this case it is equal to the number of prime factors. Okay, so big O of prime factors is the space requirement. Okay, cool. So see you in the next efficient solution. Thank you. Hello, welcome back. So this solution is going to be based on the fact that composite numbers come later. That is, prime numbers come first and then comes the composite numbers. And also, when using this approach, there is no need to use or check for is prime. Okay, so this efficient method, let's see how that works. So efficient approach. Okay, so basically I will give you a clue as to what has to be done first. So for example, let's say we are looking for the prime factors of number 450. Okay, so initially our I is at 2. Okay, let's say, and also output array is empty. Now we will check whether I is equal to 2, which is a prime number, is divisible or prime factor of 450. It is a prime factor, right? Because it is divisible. So now what we will do is like output becomes 2, and then we will divide 450 divided by 2, which is 2, and then 225. Okay, this becomes 225. Now again we will look whether 225 is divisible by 2. It is not the case. So now what we will do, we will change I is equal to 3. Remember, now output is 2. Now what we will do is, we will see whether 225 is divisible by 3. It is indeed divisible, right? It goes 75 times. So the output becomes 2, 3. Okay, and we will again check whether this number is divisible by 3. Yeah, it is again divisible by 3. So now the output becomes 2, 3, 3. Okay, and 75 divided by 3 is 2, and then we will have 5, so 25. Now 25 is not divisible by 3, so I becomes 4. If you remember, I said we will not be checking for is prime, right? So now, but automatically what happens is that, because of the fact that composite numbers comes later, this number whatever we have is not going to be divisible by this composite number, and hence we will ignore this step. And now when we come to I is equal to 5, it is indeed divisible, so we will add 2, 3, 3, 5, and 25 divided by 5 is equal to 5. Got it? And again we will be dividing it by 5, so it's kind of like 2 into 3 square into 5 square. Got it? So this is how the solution looks like. So 25 into 2, which is 50, and 50 into 9 is 450. Okay, great. So this is how the solution works. So let's see how to solve this using the programming language. Well, let's see how to do this in JavaScript. So basically inside this, I'm going to create another function called prime factors, and let's name this prime factors 2. Okay, and then we'll get the number. And as usual, let's get ready this output array. So output is equal to empty array, and we will also do the similar check, like if number is less than or equal to 1. If that's the case, we will just return the empty array. And the next case is, what we will do is like, we will add a loop, for loop, and this time let I is equal to 2. It's the same, but where is the change? This time we are going to do until square root. So I times I less than or equal to num. Okay, and then we will do I plus plus. Inside this, what we will do is like, while the number is divisible by I, which means number percentage I is equal to 0. So until this is the case, what we will do is like, we will just push these prime factors into the output array, as well as we will divide the num by this prime factor so that the number gets decreases. Okay, great. But so this is how it will be continuing. But now what we need to do is like, at the end, you need to also check if num is greater than 1. If that is the case, then you will also do output dot push of num, and then at last we will just return the output. Okay, the reason why we are having this if of num greater than 1 is, let's give you an example. So let's take an example. So let's take an example of 28. Okay, example 28. What we will do, we will divide 28 divided by 2, correct, initially. So this will go. So what happened? We will get 14. 14 will in turn be divisible by 2. So we will get 7. But now 7 can be divisible, right? Now the 7, if you see, it will come out, right? So in the case of this program, 7 times 7 is greater than or equal to, or less, it's greater than the number actually, but it is a prime divisor, right? So that's the case why we have, if number is greater than 1, then we push the number. So it's the left out number which we are trying to push. Got it? Cool. So we return the output. So now let's change this function. So prime factors of 2, 2, 2, 2. Now let's try running this again. You see, we get the same similar expected output. Great. So now that I have shown you one efficient solution, if you remember from the power, we can make this 3 times faster, right? Based on the fact that if we divide initially with the 2 and 3. So try to do that, like how we did it for prime factors, and we will see in the solution video. Thank you. So welcome back. Hopefully you're able to solve this problem efficiently. If not, yeah, let's do it now. So let's create a new function called prime factors 3, and this takes num, and inside this, as usual, what we will do initially, we will create an output array. So let output is equal to empty array, and then if num is less than or equal to 1, then we will just return the output. Okay, if not, what we will do is like, if you remember, we initially need to check for the divisibility of 2. So num modulus 2 until it is equal to 0. What we will do, we will just do output dot push of 2, and then we will also reduce the number by dividing it by 2. So num divided by 2. Cool. After 2, what we will do, we will do the same thing for 3. So num percentage 3 is equal to 0. So until it is divisible by 3, we'll do output dot push of 3. Remember, we are just trying to do the same thing like what we did for prime number, nothing different. Only thing is different is that we are all pushing it as well as we are dividing this number. Okay, and num divided by 3 this time. Now that okay, let me zoom in a little bit. Now that we are done with this, both 2 and 3, let's start the loop. If you remember, we start the loop from I is equal to 5, and then it goes till square root of number, right? So I into I less than or equal to num, and then we will increment the I by 6, correct? So inside this, what we will do is like, we will again do this while num modulus I until it is equal to 0, we will do output dot push of I, and then what we will do, num is equal to num divided by I. But this alone is not enough. Remember the plus 2 case, so we will also check for that. So while num modulus I plus 2 is equal to 0, so until this is equal to 0, we will do output dot push of I plus 2, and then num is equal to num divided by I plus 2. Great. So now once we are out of this loop, there might be some prime factors that are greater than 3 right this time, because for less than 3 we are checking here explicitly. So we will do if num is greater than 3, then what we will do, we will do output dot push of num, nothing else, and in the end we will just return the output. Great. So now let's change this from prime factors 2 to prime factors 3. So I'm changing it, and now let's try running this code. Okay, so yeah, as expected, 2 to 3, 13, 3, 3, 5, 7 is expected value, right? So 12 it should give you 2 to 3, and then 13 gives 13, 3, 1, 5 gives 3, 3, 5, 7, and 1 gives empty array. Great. So that's all for this video, but let me tell you like how this seems to work. So as usual, if you remember, let me change the color. 1 is not a prime number, and we also divide by 2 and 3. So let's get rid of that. So 4 is the thing is, what I want to share here is that why we are not looking for 4 and 5 is that 4 is also a factor in some cases, right? But the thing is, 2 is actually a factor of 4, which means we are covering all the 4s inside this 3 itself, I mean 2 itself, because 2 times 2 is 4, right? So hence we are not taking this into account. So hence the way which we worked out with the prime factor works here as well. Okay, so just a small clarification. So let's see in the next video. Thank you.